All right, and the last step on our point statistics journey here is the Getis or G, high-low clustering, and I'm sure I've butchered that pronunciation. But this is one that I think is going to be most useful for some of your final projects, and it is asking, given that these values exist at these points, and these points are what they are, they're located wherever your point data happen to be located, are the attribute values that you actually find at these locations different from what you would expect if they were randomly distributed amongst those same points? So you have point data with an attribute, could be deer harvest numbers, could be moose surveyed, could be population density is what we're working with now. But let's pop on over to our data set here, and we are working with population density. And that's the attribute we have here. Let's go ahead and display that by a proportional symbol so we can visualize this trend. So quantities, graduated symbols, and population per square mile. And if we zoom in on the city, then we'll see there's some apparent patterning here. So we have higher population densities here and lower population densities here. And there's potentially some pattern throughout the rest of the data set. Now, what we really want to know, we want to put the numbers to that, and that's what this tool does. And it's comparing to a random assignment of all these values to the same points to ask the question, is this a clustered or a not clustered data set, or a randomly distributed or non-randomly distributed, a patterned data set? And there's our input point data. The input field is the population per square mile, and I would like to generate the report. And there's some options here. You are welcome to look into them, but I'm happy with you just accepting the defaults for the purpose of your work here at this level. So we're going to accept those defaults. We do want the report, and we are going to hit OK. And it's just letting us know that we're looking at 2.1 kilometer neighborhoods here. And the observed general G versus the expected under a random distribution, and indicating that the p-value is very, very small, indicating that there is a very small chance that this is due to chance. So I'm going to close that because it's a lot easier to look at the graphic, which is accessed through the Results tab here, so Geoprocessing Results. And then here is the report file that lives somewhere on your desktop, and you want to make sure you save that, because this is the figure you can drop straight into your final report. And this is indicating that this has high clusters, so the high values are clustered. And it is very unlikely that this is due to random chance. So given the z-score of 83.67488744693, there is a less than 1% likelihood that this high clustered pattern could be the result of random chance. That means there is a pattern that you need to explain. And in our situation, it's pretty obvious that the people are living in cities, and there's higher population densities in cities. That's not a very mysterious result. But if you had a question of why do you have more crime in this location versus that location, that's something that you would want to seek to explain. So this doesn't tell you why there's a pattern. It tells you that there is a pattern that you need to then seek to explain. So if you were running this for deer harvest numbers, you say, yeah, there's clustering in this data set. Why? And then that is the subject of your project. So object of the game is to put the numbers to whether or not there is a real pattern in your data set, and then seek to explain that pattern. And that is enough for one day. I wish you luck. I will see you next time, and stay safe and healthy till then.